Hello. In my previous video I've described an algorithm that causes circular motion of a discrete particle. Link to that video is in the upper right corner now. In this video and in future videos I will try to show that a connection might exist between this simple algorithm and the mysterious quantum mechanics. I should remind you the main idea of the algorithm. The current state of a particle is defined by energy x along x-axis and energy y along y-axis. Energy can be negative. On each step particle can move only along x or along y-axis. The direction of movement is defined by whether energy along this axis is positive or negative. Weighted random events update the state of the particle and the direction of particles' movement just enough to cause circular motion for particles with large energy. Let's launch 5,000 particles with the same initial energy x equals 2,000, y equals 0. As you can see, the distribution looks tilted. It happens because of the way the mentioned algorithm works. Every particle is defined by energies x and y, and the larger is the sum of absolute values of x and y, the more time is needed for one full rotation. Algorithm works the way that the total energy of a particle can either grow up or fall down or stay the same. Low energy particles rotate faster and their radius of rotation is smaller. High energy particles rotate slower and their radius of rotation is larger. Particles whose energy did not change find themselves somewhere in between. That's why the distribution looks tilted. As time passes, low-energy particles find themselves farther and farther from the rest of the particles, and at some moment they appear to have made one more full rotation than the high-energy particles. And we get something that could be compared with a wave behavior in quantum mechanics. We see that after specific amount of time there is some probability that particle will find itself in one position if it lost energy, in another position if it gained energy, but the probability to find itself between those positions is lower. Similar situation we can see in quantum mechanics, where particles are more likely to be observed in some specific positions and states. As particles continue motion, wave behavior becomes less and less visible. I believe in statistics it is called normalization. Random or pseudorandom events keep happening and the pattern vanishes in the noise. So what do we have? We know the initial state of a particle, but we cannot know where we will find it in a specific moment of time, because it is navigated by random or pseudo-random events. We cannot know in which order those random or pseudo-random events will happen, therefore we cannot know the position of the particle. The order of events does matter. We can know only the probability, where and in which state particle can be found. For that we would have to be lucky enough to find some mathematical formula that matches the required distribution and provides a way how to calculate the probability from that function. Let's compare this with what quantum mechanics states. In quantum mechanics, particle state is described not by its current position and momentum, but by a wave function. That wave function describes the probability to find a particle in specific location. With time, quantum decoherence happens and wave behavior turns into normal behavior. Wave vanishes in the noise, just as it happens with our algorithm. So what if our distribution and the probability to find a particle in specific location described by wave function in quantum mechanics are the same thing? What if quantum mechanics represents the sum of huge amount of random or pseudo-random events that happen according to some algorithm that is yet to be found? What if decoherence is normalization? To be more specific, those random or pseudo-random events would be the interactions of the particle with other particles. Particles that are near enough would exchange energy one with another, and as a result energy along axes would grow up or fall down. Just as it happens in our algorithm. And just as it's described in other videos on this channel. Depending on the sequence of interactions, particle can find itself in different locations and have different states, but as some of interactions cancel each other, only results described by a wave function are possible. Wave function collapse would be getting information on what exactly have happened to the particle and also updating the particle. Particle is updated because observation happens through interaction and interaction updates the particle. Therefore, after observation, the state of the particle is only partially connected with the state it had before the observation. I've explained that in details in one of my previous videos. In that video I've also explained why Bell inequalities are not a problem for this local, real, discrete model of universe. Link to that video is in the upper right corner now. Regarding squared modulus of the wave function, I hope to explain the connection between the squared modulus of the wave function and the probability to find a particle in a specific location in a separate video. Actually, I've already had a video explaining that. You just need to watch it. Link to that video is in the upper right corner now. Calculating probability using wave function would be just as counting dead and alive cats independently and then merging statistics. Please note that the algorithm used in this video is very simple. It describes particle rotation in a stationary field, where field is probability or frequency of specific events. More complex algorithms, non-stationary fields could lead to more complex resulting patterns. One such pattern was described in my previous video about the double-slit experiment. It explains what could happen in the double-slit experiment without any need for photon to pass through two slits when it's not observed. Link to that video is in the upper right corner now. That video includes predictions. In the previous video I've also shown that this algorithm is connected with the complex valued exponential function, which is widely used in quantum mechanics. Yes, I claim that this algorithm has something to do with the way our universe works. I should remind you that all videos on this channel are connected together with the same logic and the same main idea. What if our universe is a huge robot? What algorithm it could follow, what prediction such assumption would lead to? So what if it is? What if quantum mechanics does describe behavior of discrete machines? What if those machines are the only beings that really exist in our universe? Why assuming that explains so much? If what I describe is true, we are having a scientific breakthrough here. I hope someday someone will finally take me seriously. Because if you did, you would probably participate. If what I describe is true, it will be a new field of fundamental study. A field that will replace what theoretical physicists are doing now. We might be able to control matter on a new, not ever imaginable level. Think about it. Thank you for your attention.